11, 17. All right, today's lesson's a lot easier. Technically, I think we almost did the hardest lesson first. Yeah, I don't know why the hell I wrote 7. 10.4. Today's lesson's pretty simple. Okay, today we're going to add, subtract, multiply matrices. Okay, so for example, let's say I have 2 matrices. Let's say this guy's x, this guy's y, let's say this guy's x minus y, and this guy's x plus y. Okay, and this guy right here is 3, this guy's 4, they don't know what this guy is, and they don't know what this guy is. Could I go ahead and solve for x and y? Do I already know what x and y is? What do you guys think x is? 3. You see how it's a 2 by 2 matrix equaling a 2 by 2 matrix? So therefore, if they're the same, that means the elements better be the same, right? So y would also be 4, correct? So what would be x minus y, or the second column first, second row first column? This would be 1, negative 1, you are correct. And then the other one would be 7. So could I go ahead and fill out matrices if I knew that? Not too hard, right? You are so kind. I'm going to even put lemon and lime. This drink right here was good. Well, I wonder what... Huh? Yeah, it was Chicago dog today. The funnel cake was good. The funnel cake was delicious. And then we had the drink. And then there's potato salad. She likes potato salad. She cooks that a lot. And I liked it. Ooh, look at, oh yeah, I would squeeze that damn lime. I love fruit in my water. What? What are you talking about, Willis? Does anybody even know that reference? You do? What's it off of? Do you even know? He's a cute little black kid. What you talking about, Willis? Oh, shiz. I had it, and then as soon as you asked me. Nope, Silver Spoons. That was a good show, too. The kid got it right around his freaking... We're recording. We're going to multiply 2 matrices together. So I have 2, 1, 0, negative 2, let's say. And we'll call this matrix B. We'll call him 1, negative 2, negative 3, and negative 1. All right. Since I said 2. Boo, 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 boo. All right. So we're going to do matrix A times matrix B. Okay, so what I'm going to do here, the key thing about matrix multiplication is you have to know the dimensions of how I'm timesing it. So this is 2 by 2 by a 2 by 2, correct? For me to multiply in matrix multiplication, the inner 2 dimensions have to be the same. And the reason being is I'm going to take this column, this row right here, and multiply it to this column. So therefore your rows, or the number of columns that you have, better match the rows of the second one. Does that make sense what I'm saying? Notice I have 2 rows here and 2 columns here. So those columns are going to match up with these rows. So here's what I'm going to do. I'm going to times this 2 by this 1. So basically, guys, I have my fingers and I'm going to flip them. Does that make sense kind of what I'm doing? I'm timesing this 2 by this 1 and I get 2. And I get this 1 and I'm going to multiply them by this negative 3, which I get negative 3. And then I add those together. What's 2 plus a negative 3? Negative 1. Now notice that begins of my new matrix A times B. Okay, that begins because this was the first row by the first column. Guess where that result goes into? First row, first column. Does that make sense? See how I'm in first row, first column? You guys see I'm going to now times I'm going to take this row. I'm going to show you one more time. Yeah. So what I did, let's go back. I took this number and I multiplied it by 1 and I got 2. I took this number 1 and I multiplied it by -3 and I got -3, and then I added those together. 2 minus 3 is -1. Okay. Now I am going to go ahead and take this row and multiply it by this column. Notice this is first row, second column, so guess where my result should be in? First row, second column. Does that make sense? So when I do so, I'm taking 2 and multiplying it by -2, and I get -4. And I get 1 by -1, and that's -1. And I add that, and I get -5. Okay, now notice I've done the first row to both columns. So now what do I need to do, you think? Take the second row and go into both columns. Does that make sense? How many of you guys remember seeing some kind of a matrix on your ACT? There's usually one question. So I'm going to go 0 times by 1, which is 0. -2 by -3 is 6. 0 plus 6 is 6. Yes, no, maybe so. Is everybody okay with me? No problem. Now I'm taking, let me just get my highlighter and that might help you. I'm taking this row, multiplying it to this column. So what I did there, notice first off this was negative, I think this was just 1, and this is -3 because we're starting to overlap it a little bit. So I'm taking 0 by 1, which is 0, -2 by -3, which is 6. And what's 0 plus 6? 6. And notice that was from the second row, first column. So where should that result be? Second row, first column. You got the All Blacks on today. Now, let's get the last one, which is second row, second column. So 0 is going to be multiplied by -2, which is 0. -2 is being multiplied by -1, which is 2. 0 plus 2 is 2. Okay, now let me hurry and just show you something pretty interesting. If you noticed, for me to multiply, the inner two terms had to be the same, correct? What is my dimensions of this one right here? It is a 2 by 2, correct? Would you guys agree with that? Guess where I could have known that before I even did anything? They're right there. Now, do you guys agree that 3 times 4 and 4 times 3 are the same thing? 3 times 4 is 12, 4 times 3 is 12. Okay, so our whole life we've understood the commutative property, meaning A times B and B times A would be the same result. Not with matrices. It will not. We're going to now show you B times A. Can somebody help me out with what A was again? 2, 1, 0, -2. And then what? What was B? 1, -2, -3, -1. Okay. Is everybody there with me? Let's go ahead and do B times A. So that's 1, -2, -3, -1. A is 2, 1, 0, -2. I'm going to be a little bit quicker on this. Notice, am I allowed to times these together? Notice this is a 2 by 2 and a 2 by 2. Am I able to? Yes, because the innermost terms are the same. You always have to check to see if you can because of the innermost terms. Is everybody there with me? Yes, sir. Then it's not possible. Okay, so here's what we would get. I'm going to do this a little bit quicker, so just keep up with me. Notice 1 times 2 is 2. Negative 2 by 0 is 0, so that would just be 2. 1 by 1 is 1. Negative 2 by negative 2 is 4. 1 plus 4 is 5. Is everybody with me on that? Okay. Negative 3 times 2 is negative 6. Negative 1 times 0 is 0. Negative 6 plus 0 is negative 6. Now notice this is b times a this time, right? Negative 3 times 1 is negative 3. Negative 1 by negative 2 is 2. So negative 3 plus 2 is negative 1. Is b times a and a times b the same matrix? But they're not, are they? So therefore, that's just an example of saying that a times b and b times a are not the same. It just so happened that that was the case. Doesn't mean it's always going to be that case. Okay, I'm going to keep a again, which was, if you guys will help me really quick again. Uh-oh. Okay, good, because I don't want you. What the hell? I did. But once again, I've been trying to do one good sit-down lesson so everybody can hear me. So if anybody misses. Yeah. All right, who was A again? All right, so that's it. Now this time I'm going to do a new matrix called C. 2, 1, 0, 0, 1, 2. Can I multiply those two together? Can I multiply A times C? Let's check. Well, A is a 2 by 2, and C is a 2 by 3. Am I able to multiply them? Yes, because, once again, why is that the case? Because those inner terms are the same. Can anybody tell me the new dimensions of this new matrix I'm going to get? I should be getting a 2 by 3. So once again, could I multiply m by n by a n by a? Could I multiply those two together? Sure. What would be my new result? M by a, right? Does everybody get that idea? Okay. Because once again, what's going to happen here, I'm going to erase this, but really what's going to happen here is that I'm going to take these two rows and I'm going to multiply them into the 3 columns. So therefore, I'm going to take row 1 into 3 columns, so I should have 3 distinct destinations, or a 2 by 3. So that's the only time you can multiply. Can I multiply C times A? Because I have a 2 by 3 and a 2 by 2, so that's not possible. Okay, I am not allowed. And that just shows you again that matrice multiplication is not commutative. Does that make sense to everybody? Rows by columns. So that's just another example of showing why it's not commutative. Okay? Really, is this hard? We haven't killed anyone, have we? It's just interesting to remember the right? My teacher put like fingers, like, oh, this finger's on, my pinky finger's on 2, my pointy finger's on 1. So then I go, 2 times 2 is 4. 1 times 0 is 0. You get what I'm saying by that? Yes, sir. Yeah, come on up. You're more than welcome to grab the one that's on the ground here. Yeah. There's 3 rows right there. Yeah, that makes sense. That's a pretty cool way that I've never yeah. Thank you. Does everybody understand what he just said there? It kind of what he just did is dictated the new dimensions. So we know we're going to have these 2 rows. Is that what you were kind of saying? And then there's going to be these 3 columns. So what he's really doing here is he's taking this 2, multiplying it to this 2, this 1 being multiplied to this 0, and then what do we do to that? Add them. So when we add them, 2 times 2 is 4, 1 times 0 is 0, and so then we get 4. Then we're going to take this row and multiply it to this column. So 2 times 1 is 2, 1 times 1 is 1, 2 plus 1 is 3. Then we're going to take the first row, multiply it to the third column. 2 times 0 is 0, 1 times 2 is 2. Everybody there with me? Who taught you this? Do you mind if I ask? Gotcha. Cool, thank you. Was this a 0? Did I make him a 0? That's a 0, right? That's your handwriting that time, brother. 0 times 2 is 0. Negative 2 times 0 is 0, so then we end up getting 0. Notice that was second row, first column, hence Feynman, second row, first column. Basically, this 0 is going to just take out the top, isn't it? Always. So 0 times 1 is 0. Negative 2 times 1 is negative 2. 0 times 0 is 0. Negative 2 times 2 is negative 4. So this matrix, 4, 3, 2, 0, negative 2, 4, negative 4, would be A times C. That's the hard part of the day, guys. I just showed you the hard part of the day. Really, that's going to be your hardest. Now we did multiplication. What else do we have? Addition. So let's say I had 3, 1, 4, and 5, negative 1, 6. And I'm adding that to negative 1, 2, 3, negative 3, 2, 1. The key thing about adding or subtracting matrices, unlike a multiplication of matrices, multiplication didn't have to be the same dimensions, did it? But when I'm adding or subtracting matrices, I have to have the same dimensions. And the reason being is because I'm going to try to say, okay, this element is 1, 1. Would you guys agree? And so is this element 1, 1, correct? I'm going to add elements 1, 1 together to make my new matrix. So 3 plus a negative 1 is 2. 1 plus 2 is 3. 4 plus 3 is 7. 5 plus negative 3 is 2. Negative 1 plus 2 is 1. 6 plus 1 is 7. And that would be my matrix A plus B. What would I do if this is a minus instead? So let's erase this. A minus. What I might do is make this a plus and change all these values in here just by a negative, or you could do it yourself, 3 minus a minus 1. That would be 3 plus 1, which would be 4, correct? 1 minus 2 would be negative 1. 4 minus 3 is 1. 5 minus a minus 3 is 8. Negative 1 minus 2 is negative 3. 6 minus 1 is 5. We're doing okay? Not hard, right? Do you guys think this is too bad so far? Nuts. Huh? We just did a subtraction. Yeah. Yep. Have the same dimensions. Now, somebody asked me, what do I do on division of matrices? We don't ever divide matrices. We times by its inverses. Okay, and we'll learn about inverses next class period. So the next thing that we're going to do is we're going to solve this equation, matrix X. We're going to solve for matrix X if I know this. Okay, so let's say I have A. Who was our A? We'll just use our ones that we already had. And I just made that up, by the way. Hopefully you guys know that. And B. Is everybody with me on remembering those A's and B's? This is our really almost our last step. We have this one and one more problem. Nice day, huh? Okay, so really, how would I solve this without knowing that this is matrices? What would you guys do? How would I solve this problem? You would know that 2 times X, or matrix X, is A plus B. Well, can I add matrix A plus B? What is matrix A plus B? 3, -1, -3, -3. You guys see how I did that? A plus B. Yes, is everybody good? You need me to scoot that up? So you decide what you're going to do? You're doing it? Just go for it. I agree with you. Oh, really? They used to have, when I registered, it was 2000, right? But they would have, like the college I was going to, they'd come down into Utah County and Salt Lake County at certain places, and they'd help you register and set up a schedule. Yeah, so. All right, guys, how do I solve for matrix X? Yeah, because we don't divide, do we? So therefore, we times by a half. Now this thing gives me just matrix X, right? Well, I got to times this side by a half as well. This is called a scalar. And what that scalar does is just times the whole matrix by a half. So what would be the new matrix after this? 3/2, -1/2, -3/2, and -3/2. So that would be the matrix that would solve that equation above. Okay? Now, to be honest with you, as I talked to you guys last time, matrices are really nice for gathering data. Right? That's really what matrices are good for, is gathering data. So let's say we were having a yard sale. Okay? I'm coming to the yard sale, Chancellor's coming to the yard sale, and who else wants to come to my yard sale? Oh, Sadie wants to come to my yard sale. Okay, we're all going to bring just these specific items, though. What items should we bring to our yard sale? So we have clothes, stuffed animals, because we always see those, don't we? And maybe chainsaws. So I'm going to bring 50 items of clothes, 10 stuffed animals, and 3 chainsaws. Chancellor, how many clothes are you going to bring? No, you tell me, brother. He wants to bring 12 clothes items. How many stuffed animals? Got some stuffed animals around? Some 6 of them? How many chainsaws? 4 chainsaws. Okay, Sid, we know your clothes is coming. Only 10? Well, what if they haven't been used in a long time? We'll go make that 40. Okay, how many? I see you as a collector of stuffed animals, though. 20 stuffed animals. And how many chainsaws are lying around? Just 1 chainsaw. All right, but we sit down and negotiate. Hey, our clothes are in good conditions, our stuffed animals are kick-A, and our chainsaws are well worth their money. So we're going to come over and say, okay, well, our clothes, each item we're going to sell is for $2. Okay? For the stuffed animals, we're like, hey, you know, these are not as good, so we're only going to sell them for $1. But those chainsaws, They're at least $100, aren't they? Correct? How much money potentially could I make at this garage sale? Would make sense, right? Would make sense that I do so, because notice this is 50 items, and I could times that by $2 to say, oh, well, BJ's getting $100 in clothes, $10 in stuffed animals, $300 in chainsaws, so that's $410 that Mr. Roberts or BJ right here is going to get $410, right? Is that what I just said? And notice it makes sense the way I organized it, because look what I did there. I took my, BJ's, items and times it by the cost to get my new number. Right? Now I'm going to take Chancellor's items. 12 by 2 is 24. 6 by 1 is 6. So now we're at 30. But he's got 4 chainsaws. So that's $400. And $30 for Chancellor for him if he sells all his items at the yard sale. Okay, and then Sydney, I don't know why I said Sadie. 40 times 2 is 80, plus 20 in stuffed animals. That's 100, plus another 100 she's bringing. She might get $200. And that will tell us what each of us could make at this yard sale. Do you see how that's a very, it just kind of aligns your data, align the cost, right? You can figure out the proportion or whatever it is. Now, the last thing I want to show you is, ladies and gentlemen, I'm going to write this. Let me find a good equation. I want it to be nice. That lady was a little bit scary. Sorry, I misstarted. All right, here we go. Let's multiply those two left matrices and see what we get. So we're going to multiply this. Is it a possibility? This is a 3 by 3, and this is a 3 by 1. Is it possible to multiply those? What should be my outstanding amount? And notice it is, because here's a 3 by 1, because it's going to equal that matrix over there, right? Here's what we got. You ready? I'm going to take this row, multiply by this column. 1 times x is x, negative y, 3z. Add those together. I get x plus y plus z. Then I'm going to go 1 times x is x plus 2y minus 2z. And then 3x minus y plus 5z. Notice those are our matrices. That is our 3 by 1. Notice I have 3 rows by 1 column, correct? Because it was 1z, I think, wasn't it? 3z, sorry about that, thank you. Oh my hell, look at you catching me. Yay, Maddie. Maddie Dunnesper. Are we missing Tasia today? Where's she at? She decided to stay lunch with her mommy. But notice that's our 3 by 1. And what did our 3 by 1 equal? 4, 10, 14, right? And what do we know about if matrices have the same dimensions? Then they equal each other. So didn't I just basically write our equations? I'm going to show you why this is nice in just 1 second. So basically, I changed it from kind of like an augmented matrix, or a matrix equation is what we call it. Okay, we just changed that matrix equation into a system of equations, didn't we? Okay, now watch what would be really nice. What if I just called this matrix A, this matrix B, and this matrix C? We're not doing this today. This is actually going to be in our next time's lesson. But wouldn't it be nice just to get rid of matrix A to the other side, and then I'd just be left with X, Y, Z? So what I do is, remember, we don't divide. We times by their inverses. And we're going to find their inverses next time. So what I times to one side, I got to times to the other. And so then A's inverse times A gives me just our 1, our identity. Because what's 1/2 and 2? Aren't those inverses? Right? When I multiply those, don't that always give me 1? Does that make sense what I'm saying? So therefore, then I'd solve, and then I'd have this matrix multiplication that I'd do over here, and that would tell me what X, Y, Z is. So that's just a different option besides doing row echelon form and reduced row echelon form. This just gives you another way to solve. That's what everything in matrices are doing, is teaching us other ways to solve for X, Y, and Z. Does that make sense to everyone? All right, that's it. So with that being the case, your homework is on 10-4, 5 through 47 odd.